Good morning, everybody. If you're on the West Coast like me, you're probably still in your pajamas. If you're on the East Coast, you're probably having some brunch. But thanks for joining us this morning from coast to coast here. Today, we're going to have a look at installation and application for our new Vitodens 200 boiler, the B2HE. And joining me today out of Waterloo, Ontario, we're still socially distancing, I guess, remotely here. I even showered. These guys still don't want to join me here. Mark Norris and Curtis Scharholz are with me this morning, and they are going to look after some of the question and answering as we move through here. How are you guys doing this morning?
Excellent, Scott. Thank you.
Oh,
good, Scott. No, it's not that you didn't shower. It's just that it's a long walk to your office from here.
I guess so, yeah. I was playing the whole virtual game there, but
yeah.
Anyway. So we're going to have this recorded. We're recording this as we go through here. This will be archived. I think Mark is already through some warp drive has our 100 application installation already up on our YouTube channel. So if you missed that, you can always go back and have a look at that. There's a lot of similarities between these 100s and 200s, and some information on the 100. It's a bit more of a kind of that entry basic model. We're going to kind of cruise through that here on the 200. It's a bit more of an advanced boiler here. A lot more information to deal with. So I kind of want to jump right into it and get going. We got about I think we have 2 hours here. Mark and Curtis are going to keep me on track, hopefully. And
yeah, I will remind you at the 1 hour mark. How's that?
Sounds great. Sounds really good.
And if you have questions, guys, put it in the Q&A box, please. We will try to answer the questions as we go along here. Anything we don't get to, we'll do at the end.
Mm-hmm.
But if you answer it in the Q&A box, we can send you a PDF of all the questions and answers to everybody, so that there's a question you might say, "Oh, I wish I had remembered that." You'll have it. So,
right on. So let's jump right into it here. We'll get going. First thing to have a look at here is just as we mentioned, these are new boilers that we're bringing out, and a lot of changes. Not just, cosmetic changes. So everything from the boiler casing has changed. We've gone with a Vitotrol white casing on the cabinet now, or paint, and it's kind of a matte color, so it's not a glossy. So it's kind of like you see now in the automobile industry, a lot of vehicles out there now with these kind of matte colors, nice flat kind of really good looking color. So as far as the cabinet goes, it's changed quite a bit that way. The door has gone through a substantial change here as well. So it's something as small as a door. That's a fairly important part or component of the boiler here. We're gonna have a look at that, what changes were on that as well. Internally of the boiler, so we're looking at what your kind of the meat of the boiler, the heat exchanger and the burner. That's gone through a very large consistent change here as well from the previous boilers. Everything now is stainless steel on our heat exchanger. So anything in contact with the condensate potentially is now made of stainless steel. So that's a robust metal in condensing boilers. Basically, it's proven as the kind of the choice there when we're dealing with kind of a metal. We need to have a passive kind of a reaction to that corrosive condensate. We're gonna have a look at that as we move through here, what we need to do with that condensate as we install these boilers. But just thought I'd mention that there's a big change there. As well as on the burner. So the burner has gone through a big change. The burner tube is basically, as the sock is gone now, it's a complete stainless steel tube there, which changes basically the ability of the burner when it emits like greenhouse gases. So things like NOx levels, et cetera, have substantially been reduced as a result of that. And on the combustion side as well, we've added an airflow sensor. So now your boiler, even though you have no idea why you're standing in front of it, is continuously reacting to things like wind, altitudes, obviously the quality of the gas that you're putting into it, the vent lengths. So all those things are now being kind of addressed with a mass airflow sensor we've added into the boiler as well here. So lots of changes on that side, and look forward. We did an overview of this a couple weeks back, and if you're interested in some of that stuff, there's a better review of that on those overviews that are now archived on our YouTube channel. But we will be coming out in the near future here with some service presentations, and then we'll cover more of that stuff as we move through there on that. But just so you know that there's been some changes there. And as well as we've changed the blocks, the hydraulics of the boilers as well, moving through. So now it's a more of a platform. So it goes right across the portfolio, 100s and 200s, and that basically allows us to kind of streamline our production. And of course, economies of scale there allows us to basically, we don't have to change up things or retool. It makes things go a lot more efficiently on the production side. So we've changed some of that stuff. We're going to look at those as we move through. The new boilers, 200s now are kind of our 4-pipe design, and we haven't had that on 200 since the WB2A. So those guys that are sitting here, taking this in, you remember the WB2A with the 4 pipes, the 2 for spacing and 2 for domestic. We're back into that as far as the 200s, but beefed it up with some extra components in there as we review. We're down the bottom right-hand corner there. I got to kind of peek over my laptop to see it. The control is different between the 100s and the 200s. So the 200 here is it's a 7-inch color touchscreen. It really pops. You're in those boiler rooms that the lighting's not quite so good. This really pops when you're kind of looking at it. The color is really going to draw your eyes to the areas where you want to, start to navigate through the control. And lots of areas in the control to kind of work with there. Lots of different, relay tests and diagnosis areas to help you troubleshoot the boiler, looking at set points and actual temperatures and stuff like that. So lots of information there, and really good kind of, packeted information as you move through the control. And the boilers have also, we're bringing out, are complemented with a line of digital tools. You kind of see those there. And I'm just going to briefly talk about those, not spend a lot of time on them, just so you know that they're out there. We have done some in-depth training. The guys from the US, instructor Patrick and Jody, have done a really good job of kind of detailing a lot of information on these digital tools already. If you want to have a look at that and what these tools can do for you in a more kind of drill a little bit deeper into them, you might want to take in those archive presentations that are on our VSBN North America YouTube channel. So the first one to look at is the V plan. It's kind of the first app, or this one here I think is a web-based application that we'll be looking at, but it's from start to finish. So this is like when you first show up on the site and there's a whole conceptual idea of what this heating system is going to look like. And it takes it right through to the final portion where you're basically commissioning the boiler and all that kind of stuff. And it allows you to basically detail everything along the way as you're planning that installation, with the decision makers as you move through. So there's a VI plan or V plan that's available. The VitoGuide Mobile is for the technicians out there. So the guys out there that are going to be doing the installing, the guys that are doing the service work, regardless of your kind of what you're doing with the boiler as the technician, the VitoGuide Mobile is really handy. So it's going to allow you to commission the boiler using your digital device. All the boilers have a hotspot now built into them. You can stand in front of it and pick that hotspot out. Now you can commission that boiler on your phone, or you can do it on the interface on the front. Mark and Curtis are going to detail that in a couple weeks about when they do the startup and commissioning presentations. You also have things like spare parts areas and stuff like that. So when you're doing service, you need igniters, etc. Very easy now that you have the boiler linked to your digital device to basically explode diagrams of the parts of that boiler and the part numbers. So you know with confidence when you order things that you're getting the right parts for those boilers. And we've really reduced the number of parts, the spares that you need for these products. And they're universal now across the 100s and the 200s. Pretty much as far as the burner controls and stuff like that go. And like as I mentioned, there's now you have the ability to remotely view that boiler if you hook that up eventually to the Wi-Fi connection of the building or home as we move through. So the VitoGuide is for the contractors out there, VitoGuide Mobile. VSBN Techs also have a VitoGuide capability, and if we get permission from the homeowners, we can actually see those boilers remotely as well and kind of dig a little bit deeper in there. So as far as tech support on these boilers, it'll be second to none because we have the ability now to essentially remotely view what you're seeing in those boilers when you're standing in front of it. And then we have the VCare mobile app, and that's just for the homeowner. So if they choose, they can link their boiler from that hotspot to their Wi-Fi connection of their building. And now they have the ability to adjust things for comfort, have a look at what their energy performances are, all those types of things they'll have the ability to do. And the whole idea there is that everybody that's basically connected to that boiler has the ability to relate to that boiler in the way that they are really going to need to relate to it. So your relationship as a contractor is a little bit different with that boiler than it is to the homeowner. And these apps kind of are basically, that's the kind of the detailed attention that they're trying to achieve here. So 3 apps there to have a look at if you're interested, and we have had some detailed training on those already. The Vitodens 200, when I stand in front of them, I notice they're a little bit deeper basically from the previous models. That's the big difference, a little bit heavier as well, but you can see the specs here of what they look like. Those are the smaller 85 120 and the weights of it. 150, 199, 179 pounds. So you see the kind of the weight and the dimensions there. So a bit deeper, a little bit different dimensioning to it. But actually, when you're doing the service on these boilers, you actually find that you'll probably need a little bit less space as a result of the door change on these units. Some of the engineered data on these boilers, they're low mass. You can see by the capacity of the heat exchangers, the water content, just over a gallon in the smaller boilers, 2.5 gallons in the larger ones. Your flow rates, so always be aware of those. That's going to determine whether we're going to use primary, secondary. A lot of times is the flow rate of the system higher than the flow rates, max flow rates to the boilers. There's also a low end as well. So we always know that there's a min flow rate. There's always a flow switch in these units. And if we don't meet that minimum, of course, that paddle's not going to close, that boiler's not going to fire, and we have the maximum that we see here. So if you're within those ranges, there's potential where everything would work without primary, secondary. But the consideration there is optimizing the efficiency of the boiler. Is that primary, secondary going to help that? We'll have a look at that as we move through. Operating pressures, you have a 30-pound relief valve that comes with these boilers. You have the ability of increasing that depending on this, what your static pressure requirements are for your building. So the taller the building, the bigger the relief valve pressure capability has to be. If you need something that's within a different range of 30 pounds, of course, you can order those separately to get those the pressure that you're looking for. The temperatures really haven't changed all that much for space heating, but for the domestic, I notice it's quite different. Part of the reason for that is we've eliminated the mechanical limits on the boiler now. So instead of a mechanical fixed high limit on the smaller units, at least in the previous generations of boilers, we've gone with complete electronic sensors now. So you have 2 boiler sensors comparing each other as the boiler's firing, and if there's any issues there, of course, they're going to stop that boiler from getting into an unsafe condition. Very necessary when you're getting that close to your fixed high limit, 194 Fahrenheit. And 210 with that amount of water capacity, that we have some accurate sensing, temperature sensing going on. So we've addressed that there. And 194 is the capability. It just depends on the conditions. Will the boiler fire to 194? Only if it needs to supply that domestic hot water capability. And sound ratings, it's a pretty big thing. The sound ratings, if that boiler is, next to a boiler room's next to a bedroom, et cetera, the velocity of air that we're dealing with in these larger boilers in particular, lots of cubic feet per minute of air movement, and the quieter the boiler, obviously, the less it's going to affect the occupants. So it related basically to like a refrigerator, the modern day refrigerators. I actually just bought one a couple weeks ago, and I do notice a difference between the old refrigerator and the new one, much quieter, and the ratings of these boilers are very similar to what you would deal with now, and that with that type of noise coming out of your new refrigerator in your kitchen. Turn down ratios on the units, that's something else we've been able to do now with the airflow sensor and of course the new burner cylinder, being able to handle those lower firing rates. So now we're 10-1 on the 85 and the 150 and 14-1 on the 120, 199. And those are slightly, actually significantly better than the 100 when you look at the 120 and the 199. So 10 to 1 on those blowers on the 100s, or 14 to 1 on the 200s. So it gives us a little bit more capability there on those shoulder seasons to keep that burner from cycling on and off, which keeps that efficiency at a good state at those on those shoulder seasons that we often deal with space heating. So out of the box, hopefully you have a boiler when you get it on site. And there's some other accompaniments with that. When you open up the boiler, there's a trim package that comes with it. Outdoor temperature sensor with a 200 boiler. It's a premium product. The idea there is you're buying that boiler as an investment, efficiency being the primary kind of driver there. We're trying to build an efficient heating system. Outdoor temperature sensing is necessary when we're dealing with heating systems to get those to optimize that efficiency. That comes with the boiler. Obviously, the relief valve we just talked about, 30 psi. You can order 45 and 60s if you need. You got a gauge, pressure gauge, which is part of our code requirements to have a visual of the pressure. When we get into venting, look at the air supply cover, what that does. You got your boiler drains for purging, wall mount bracket. You have a domestic tank sensor if you're doing domestic hot water. If you're not using that for domestic, you could also use it as a low loss header sensor. In that case, if there's no domestic in the system, but you do have primary, secondary, you can actually flip that to your low loss header sensor if you wish. Obviously, condensate we'll deal with. You got propane conversion stickers. Really, that's about all you have to do as far as the conversion is actually put the stickers on there. It's a program now. There's really nothing else you have to do mechanically. Your technical documentation, always important, but now hard copies are available. They come with every boiler, but if you have the Vito Guide apps and all those apps we talk about, these are all electronic as well. And electronic's actually better with documentation because it's living, which means that when there's changes to that documentation, you're going to get the actual most up-to-date manual if you use the electronic copies. Then we have the closure caps, and that's something new in our boiler trim kits, because if you don't have domestic hot water in your system, you have these caps. You can just basically thread those on because we have that 4-pipe design now to basically isolate those connections. We don't need a bypass or anything else like that in those connections. Just cap them and leave them. Something important kind of related to those digital tools I talked about. When you uncrate the boiler here, this little box, this is the 100 being represented. The part number will be different for the 200. But when we open up that box and we see the control, you flip it over, there are stickers here. And these little Wi-Fi stickers are the ones that will connect you to the boiler's hotspot. So if you want to use that digital tool and connect to the boiler with your device, this is the sticker that you need to basically, the QR code you're going to need to do that. There's a couple of extra ones here. These are the ones that are basically meant to be placed on the boiler in different areas that are more visible. So we put one right on the enclosure for the wiring panel on our 200. You can put them on the outside of the boiler. There's spots in the manuals to kind of place those so that if you, the contractor, are using this hotspot basically to commission the boiler, the homeowner will probably may want to actually link their boiler to their Wi-Fi. They'll need to have that sticker as well to do that and perform that particular procedure. Clearances, not to spend a whole lot of time here on clearances. They really haven't changed from the new to old boilers. Basically the 6-inch here, these are all service clearances. There's no clearances to combustibles that we have to worry about on anything here, from the top, bottom, left, right, front, back, right to the vent itself, right up to the roof. We don't have to worry about clearances to combustibles. The 28-inch clearance is for the service. If you had to slide this whole door out like you currently do, of course, the whole depth of the boiler is what you're dealing with there. With the new boiler door on here, it is quite a bit thinner. It squares up really nicely on the blower when you put it all back together. But you'll notice that it shows a little screwdriver down the bottom to basically release the boiler door from the boiler enclosure itself. You don't have to screw anything off here, and you're not backing a screw off here. All you're doing is pushing a little clip that releases that door. So you could use like an Allen key, a pen, whatever it is, something that's a diameter enough to kind of poke in there, and you push those clips in. It releases the door. You basically pull it up and out and set that aside. Again, very small, very thin, but it's a pretty, like I say, the way they've designed it, it's not flimsy at all. It's a pretty rugged boiler door. So you get that off. Now you can mount the boiler. We've added these little blocks on the bottom here, these little wooden blocks. The idea there is that you can pull the boiler out of its box, out of the crate, set it down right on, right as if it was when you're mounting it here. You can set it right down on the floor without damaging your hydronic connections here, your gas connection. And then you can do all your mounting of your railing here, of your mounting rail, and then pick the boiler up and then mount it onto the wall there that way. So those little feet there really make it nice and easy for you to kind of set that boiler in place first, and then when you're ready to mount it, pick it up and mount it there. Once you're finished that, you can, a couple screws hold these blocks in. You take the blocks, throw them away. You want to probably do that before you start putting your connections on here, just because that wood gets in the way a bit of your connections. So when you're putting your Teflon on or whatever it is on your hydronic connections, if you don't remove the wood block first, you kind of have a little bit of frustration there. So get those out of the way. We have the wall stands as well, or I should say floor stands. So if you don't have structure, I mean, the whole idea behind the wall bracket here is that we mount it into some structure that's going to hold that boiler and fix it in place. If that's not available, you can use a stand. So we can attach it to the floor here. You could anchor it to a wall if you wished, but typically if there's nothing on the wall to a structure, it's going to be a floor attachment. And this stand is what we're currently using for our existing boilers. Same dimensions here, so been retrofitted for that application. Notice the levels here. The whole idea, whether we're mounting the boiler on the wall or on a stand like this, is that we need to make sure it's level. Condensate flow is what we're dealing with here, really, as well as aesthetics. Basically making sure that if the boiler is flush and plumb here, the condensate, hopefully we're getting condensate out of a condensing boiler when it's in operation, has a nice easy pathway out of the boiler and into the drain, and basically out of harm's way. So different dimensions here for the boilers. And you can see it's like I say, it's a little pieced together stand, so it doesn't basically attach it or basically assemble it on site as you're going through. The height that we're dealing with. So you just look at the floor stand there. You got wall mounting capabilities. We have crawl spaces these boilers are being installed in, all different areas. Up high in areas, etc. Sometimes the height of the control here would be nice to be able to change, and you have the ability in these boilers to basically adapt that so that the boiler comes default where the controls on the bottom. It's very simple to put it up on the top here if you wish. This is a video from Europe. We played this a few times in some of the overviews, so this might be old news to some of you, but it's not that long. We've sped it up here a little bit to get an idea about how to change this out. And like I say, it's fairly easy to do. Just a couple of steps here you have to remember. The light guide has to be flipped around. The control base has to be flipped around before you put it in. And we're get her into place. These red clips are a little different here in North America. They're a metal clip instead of what we see there. And there you go. Now we've got it basically mounted from the bottom to the top. And like I say, pretty simple to do, and it really helps. Like I say, especially I know a lot of places here in our region, there's a lot of crawl space areas that are being utilized for mechanical rooms. Or behind underneath a set of stairs or whatever, and that really helps to be able to see that display and put it in the right spot. Hydronic connections, 3/4 inch right across the board. So whether it's the domestic or hot or heating side of the boiler, it's all 3/4 inch on the 85 to 120s. Your purge valves, all that stuff are the same, 3/4 inch connections. The I don't know what color that is, a blue or aquamarine. You guys might want to chime in and tell me what color that is, but that basically are all field supplied fittings. So the boiler drains that you see here are basically come with the boilers we mentioned. Everything in the outline here is basically field connections, and we show these little representations of valves right here for isolation, so that we can do the purging and the filling of the boiler, that we can isolate here and do all that stuff properly. The 150, 199, basically the difference is the heating supply, domestic supply, and return connections are 1 inch instead of 3/4. Everything else is 3/4 inch. And again, same idea. We've got the isolation valves here, recommended that you put those in this area so that you can isolate the boiler while you're doing that purge and fill, get that air out of the unit. And as I kind of mentioned here, everything basically is cold's always on the right-hand side of our boilers, and hot is on the left-hand side. So if you're going into the boiler returns, make sure you're going on the right sides and coming out on the left. Another look at the bottom of the boiler there. We're going to spend a little bit of time down here. The connections here are all capped off. The idea is that you leave the caps on until you're ready to do your piping. Remember to remove the caps when you're doing that. There is a single tool tightening capability here. These fittings are all flanged inside. I have a pretty robust connection here. We did a single tool or a pipe hours when we got them in here. A lot of guys prefer to use backing wrenches just because you can kind of control your torque and stuff like that. That's fine. There's lots of beef on here if you want to use that. I know a lot of the mechanical guys like to do that, technicians and stuff like that. And there's lots, like I say, of beef on there that you can get a backing wrench on there should you wish to do that. So either or is capable. The bottom of the boiler here as well, you've got your connections. So if you're a 200 guy, you've installed 200 boilers, the current line, one of the complaints was that the junction box currently is movable. So we got to drop it down, and basically all your connections are in there. So the connections have to be flexible, right? So your conduits and rigid conduits and stuff like that, you'd have to have some flexible portion of that so you can still move the control around. Now the bottom's completely static. So your connections are already knocked out here as well for you. So you have line voltage connections here, low voltage connections on the bottom of the boiler that feed up into the housing. So this never moves. It always basically stays in one spot. So whether you're going with hard piping your connections, your 120 volts or whatever it is, and you like to use like conduit, you can do that with these connections because they are going to stay in place. On-off switch on the right-hand side there. And then that little block area, once you take the wood out, now you got a nice spot there where you can zap tie your low voltage on one side, line voltage on the other, keep those sensor connections and line voltage connections separate so you don't have any type of interference between the two. Relief valve that comes with the boiler, again, it's you should support that. This is no different from our current boilers where the relief valves are piped off the top. I always recommend it's not meant to support the piping here down to the drain, which should be piped down to a floor drain. And it's a little bit of a difference in the fact that that pressure gauge, there's no more pressure gauge now on the face of the control on the left-hand side. With basically all of our controls, I think since the WB2A, that pressure gauge has been on the left-hand side of the boiler. Now that pressure gauge is mounted up where the relief valve is. A little tapping on the fitting that comes with the relief valve. And you thread it in there so you get that visual pressure at the top of the boiler. I like that where it sits. Relief valve is obviously a nice spot there to purge the air out. And you have the clip here and a zap strap. So we clip this double O-ring fitting in, put the zap strap on it so there's no, nobody can, unintentionally pull that clip out. And of course you got pressure and that pops. That keeps that in place. And of course you thread your relief valve on and your pressure gauge. When we get into the condensate side of the boiler, when we're installing the unit, just remember there is already a P-trap inside the boiler. It's changed significantly from P-traps were in previous 200s. There's actually now a little dirt separator in the P-trap as well. So and it's a much deeper trap. So it takes a lot longer for that. If you've got a lot of debris in there, it's going to accumulate in the dirt separator and not plug up the path of the condensate. So what we're trying to do there is mitigate, when that boiler hasn't been serviced for a couple of years, where we get that condensate moving up into the heat exchanger during operation. So let's basically make sure we have a little longer time there before that occurs. But because we have a V-trap, you don't have to put one in the piping here. So you see how this piping is nice and straight. The idea there is that we don't want to drop that diameter. So we don't want to have it 1/2 inch. It's a 3/4 inch right now. We want it to go to 1 inch to your drain here. And that should be basically it shouldn't be a tight connection here. So it should be open to the atmosphere. That would allow basically if there's any issue on the drain side here, it's not going to basically back up into the boiler. It's going to basically spill it onto the floor here. And you might get a call that you got a little bit of water on the floor versus you've got a fault on the boiler because you back the condensate up into the boiler. You get a nice amount of hose here. Cut the hose. Don't loop the excess amounts around. That's going to cause problems. You can cut it and basically put it directly into the drain as direct as possible, and then of course fill that P-trap up. When we go to the drain, now you have to remember that with condensate out of condensing boilers, you're at with gas, we're in that 3.5 to 5.5 pH range, and that will over time, anything basically with a ferrous metal, it will dissolve. So things like iron, so any cast drains, for instance, you have a condensing boiler, you've seen the effects that can happen when over time with that raw condensate going down to those floor drains. If you let it basically drain onto concrete, you've also seen the effects of that as well, where you've got now nice aggregate instead of a nice finished concrete. It will dissolve that stuff. The whole idea there is that's also going into your rivers and lakes and streams. So if you like to boat, you like to fish, you like to swim, all that stuff basically we're trying to protect by neutralizing that condensate. And a lot of areas now it's mandated anyway. So you can't put a condensing furnace in or a boiler unless you have some sort of neutralization. Important things about neutralization is the fact that condensate has to spend some time in the neutralization tank itself. So if it's too small, you're not going to get the right neutralization out of it. It needs to spend about 15 minutes or so in the tank. So depending on your BTUs, the tank has to be a specific size to make sure that we can handle the capacity of the condensate coming out of that boiler. When you buy a Viessmann tank, they're matched to the size of the boiler that you're looking at. There's no guesswork there. And there are a few tanks out there that actually become more problematic than they actually help with neutralization. So just a kind of a word out there that's neutralization tanks might be a necessity, but they're not just grab one and throw it in. They should be sized appropriately. Like any other mechanical device, there is fit there. The pump that we have in the boiler, so this should be this is very new to a 200. The previous generation of 100, we had a built-in pump. We've got a built-in pump now on the 200s as well, and it's a variable speed pump. And you see on the left-hand side, you've got a diverting valve on these blocks. So depending on the size, the smaller ones, it's a 3/4 inch connections, as we mentioned, 1 inch on these on the larger boilers here. And the pump, of course, is a variable speed as we looked at here. So you can set those speeds. The big difference between a 100 and 200 is the 100 you can set the speed. The 200 you can set the speed as well. So we got the different pump curves here, but you can also adjust the pump speed during operation. So the pump speed in a 200 boiler, you can vary the speed of that pump as it operates. And we'll have a look at that here. So there's a couple of applications here. One is weather dependent operation. So if you have a direct heating circuit and that's it, we can do weather compensation, which means that you can adjust your pump speeds, which means no primary, secondary, just straight on the heating circuit here. You can adjust that pump to basically operate based off of the outdoor heating curve. So you set your, plus 20 outside to minus 20. So, at plus 20 outside, the pump speed's at 50%, that's the minimum. And at minus 20, whatever it is, it's going to be at maximum. And in between there, that pump is going to vary its operation based on the weather. So really, you could dial in a real high efficiency delta T, et cetera. There, literally, that pump can operate exactly to design if you wish. So there's an option there for weather dependent operation. You can also just have them at fixed speed. So if you do, if you're not doing outdoor reset, you're just doing constant temperature, so fixed temperature in your systems. That's a capability here as well. The boiler pumps go to fixed speed. You have the ability, if you like, to adjust those to follow burner modulation. So we either just fix the speed, or that pump will basically operate based on the modulation of the burner. So the burner's on full fire, your pump's at at max. If the burner's on low fire, that pump is going to be at minimum flow. So the whole idea there is we're trying to match the delta T of the system here. Our boilers work off of temperature differential more than they actually do off of flow rate. And this way here, we can vary that flow rate to maximize that delta T to keep that burner in the kind of optimal efficiency. So you can play around with that a little bit and basically adjust that. And it's about fit, right? So not every application is going to, work off of burner modulation. Maybe it's a fixed speed that's a better. So it just comes down to those fits and where those are going to play. Internally, I just thought it'd be interesting to have a look at this because you can see inside of the boiler here where that diverting valve sits. You've got a flow switch in there. You got your 2 temperature sensors at the top. Return here on the left right-hand side. Difference between the return is that it's common. So we're teeing in here and everything's common. On the outlet side, supply side, the diverting valve basically separates between the heating of the system to heating the domestic hot water tank. And when we have the domestic hot water tank on the primary side of the system, we have 100% priority. So when this boiler goes to heat the domestic, it's going to block that spacing 100% while it's providing energy to heat that domestic hot water tank up. So there's a difference there between the connections here, isolated connections and then common connections on the return here. I got a point to that in a minute. We'll have a look at that. The controls inside of the boiler, basically these are all factory wired controls linked together, communication. So you've got your display unit here and a telemetry unit. It's early in the morning here, so I always trip up on telemetry. It's even worse when it's 7:30 in the morning. So that's your hotspot connection there. Those 2 pieces, that's the front piece here. We've got the burner control unit over on the side, the heat management unit, which basically is the one that controls the set points and then the pump outputs and stuff like that. The BCU here kind of controls the safe operation of the burner and all those types of things. So there's lots of communication going between these 2 devices, HMU and the BCU. You're going to be interested as the installer of the MZIO here. So this is where we have the multi-zone input-output box, and this is not in the 100, so it makes the 200 a bit special that it has this extra little box here. So this guy on the right is part of your 100. This accessory here on the left, this panel here is only in the 200 exclusive. So let's have a little quick review of this. So basically what you see is you got the 40 plug and it's already wired with a outlet here, a 3-prong plug connection. You plug it in the wall. Always make sure you've got polarity correct here on all your boilers. So line to ground must be 120, not ground to neutral. If ground to neutral is 120, the polarity is reversed. And when we're talking about burners with flame rectification, where we're looking at the ionization signal of the flame, if you reverse the polarity, you'll end up with a lot of nuisance lockouts on ignition. So a very important step, just to check to make sure that polarity is correct, especially if you didn't wire that plug, right? You don't know if that plug is wired correctly or not. So have a check of that. Once we plug that in, this 156 plug here is basically daisy chained over and plugged into the 40 input of our panel here. And that powers up the MZIO board here. Once we have the boards, we have 6.3 amp fuse on both of them. And those are basically fuse protecting, things like the pump outputs here, et cetera. So there's a load on these already. And, or will be load if you add those pumps on. The communication, we've always had communication with our boilers. That's changed with the newer portfolio here. The 74 plug connections are plus bus. They'll be for basically Viessmann components that can communicate with the 200. So there's a array of different boxes for different applications. There's room temperature controls. They wire to the plus bus here to feed back information to the board here so that they can make decisions on what it needs to do as far as processing that information. The 91 plug over here is called the CAN bus, and you're going to use that for the commercial guys out there, your building automation guys, etc. The 91 is a connection for cascading your boiler. So you're only going to use the 91 plug when we're dealing with either gateway communication or we're connecting multiple boilers together to make a boiler, basically a heating system. So, 2, 3, 4, up to 16 boilers can be connected together in a cascade system. The 91 plug, we're gonna have a look at that briefly, will be the connection for that particular application. So that plus bus can handle all of this stuff. So you can have up to 7 of these different modules for different applications. We're gonna have a look at a few of these more prominent ones for our applications today. We'll have a peek at the M1 modules and the 200Es here as we move through some of the applications. But the whole idea here, just like our existing 200s, is their accessories. And that's really what separates the 200 from the 100 is when you start getting into these more complex systems, we can literally off the shelf provide those answers for you in these particular little accessories. Interesting is, just like as I mentioned, the whole platform has been streamlined. This board, even though it does multiple functions, is the same board. So basically that one board, if you were to replace it, you have just one part number, and that one part number covers whether it's an M1, P1, or S1. It's how you program it when you plug it into the control as to what that control, how it's going to react. So the controls are basically all the same connections and stuff. That some of them just won't be used depending on what the specific type of module that you're working with there. So it kind of just relates back to that kind of streamlining of the parts in the Viessmann system. We've got zone circuits. So those are we introduced zone circuits with the last generation of 200 boilers and the Vitotrol 300 CU3A, and basically that allows you to basically hook up to 3 different zone pumps here. So these could be 3 different temperatures. They could be fixed temperatures as well, or they could be weather dependent. So you can either just say, I want zone, the zone to be every time that zone calls, it's 50 C that goes out to that system, or 122 Fahrenheit. Or I want it to work off of the outdoor sensor and follow a heating curve. So it's optional with the zone circuits what you want to do, but the pump outputs are on the left-hand side here. They're all 120 volt, about 2 amp max is kind of what we're looking at. We got a 6.3 amp fuse, so we don't want to overload the fuse. The actual call is right here. So the zone pump, ZP1, 2, and 3 are always related to the Z1, 2, and 3 here when you're using them as zone circuits. These are the thermostat connections. So whether they're power stealing thermostats, you want to wire here. You got a Nest thermostat, for instance, you want to wire up to this, and it's got the W, R, and C. You can wire this to the control directly here, and it will provide 24 volt AC power to those thermostats for that. If they're just end switch contact from a set of zone valves, for instance, or you got a zone board, it's a dry contact. You just use the 2 outer ones, the TTs here, and that's the dry contact connection there for that same application. Regardless of what type of connection you're trying to do here, these are multifunctional connections. Then there's also the ability with these, if you're not going to use them with zone circuits, the zone pumps here, they're also safety circuits. You can program these for things like low water cutoffs or high gas pressure switch connections, low gas pressure switch, that sort of thing. So these are programmable safety contacts if they're not being used for zone connections, as we see here in this application. The 96 plug, we go over here, this little contact is programmable as well. It's got multiple functions, and you'll set this up. Mark and Kirst will go through this when they go through the commissioning, but basically when you're going through whether they using the interface on the boiler or you're going through the VitoGuide app, it'll ask you what you want to do with that 96 plug. And basically, there's a couple of it could either be close a contact and we can start the recirc pump over here. So we have a domestic hot water recirc pump connected to our connection over here. When we close the contact, you program it for a recirc demand. You hit that contact, it'll run for the recirc pump for 5 minutes, and then it'll stop. You hit it again, it'll go for another 5 minutes. You can do an external temperature set point. So we still have an external set point capability. So you program a temperature, say 70 C. You got a pool or something like that you're trying to heat up, snow melt or whatever, and you want to use external heat demand, you program that temperature, and your temperature controller would dry contact would hit the 96 terminal here, 5 and 6. When that closes, the boiler basically changes that set point to whatever the external demand is, if it's higher than the existing set point it has currently. So if it's lower, it'll just stay at the higher temperature. If that external demand set point is higher than the set point the boiler currently has, it's going to drive it to that higher temperature that you're looking for. It does not control a pump. So it basically is it just operates the temperature of the boiler to a different set point for different things that you might have out there for operation. We can do external blocking. So BMS guys like that type of stuff, when they're doing different things, where they can just close that contact to 96, and now everything stops. No frost protection, no anything. The boiler just sits there idle until you release that. And there's an indication in the operation, and as you go through diagnosis and you look at the burner, if it's being blocked by this contact, it'll tell you whether that's open or closed. And then we have a call for heat. So we can actually add another zone circuit. So you have zone circuit 1, zone circuit 2, zone circuit 3. This can be a call for heat, opens up zone circuit 4 with all the same capabilities. You'll have a heating curve, or you'll have a fixed temperature, and it'll be a zone circuit 4 you'll actually see on the control. No pump output for it. However, you would use like a relay box or whatever to give you basically those 4 zones should you need that. So just a couple things there. The 66 plug is another one over here that is programmable. Typically, it's used as a fault output, but it has another function in the new boilers. And when you're going through the programming, usually you're going to program the 0 to 10 and the 66 together. That's how the address works when we go into this. So what do you want these 2 plugs to kind of do is programmed at this address 1706. And the red areas here are what you can actually program this control for here in North America. So if it's at 1, I think that's the default, and there's nothing that's going to happen. So you can play with 0 to 10 all day, but if it's basically function at 1, there's nothing's going to happen with 0 to 10, and the plug 66 does nothing as well. So just sitting there idle, not doing anything. If you change it to 5, the 66 plug will then become a fault output. So if the boiler faults for anything, it will close a contact that's a dry contact. You can take that to a building management system. You can wire 120 volt through it if you wish, and that could basically, set off an audible alarm or a light, whatever it is. If you choose 6, then of course you've got the same fault message output, but now you've got an external temperature demand. So a floating signal off of the 0 to 10 that we can do. We're gonna have a look at that in a second. The other option with the, it's at 7, is the same fault output, but now external modulation demand. So instead of a temperature demand, the 0 to 10 modulates the burner. Instead of a temperature in mind, the guy at the controls here is actually in control of where that burner is going as far as its percentage of output. We have the ability, this is the extra ability of that 66 plug in the new boilers that you can program in the software tool in this parameter 2245. And basically what this additional call for heat means is that if the boiler is in operation and you can program the parameters for this and it's not keeping up with the system, you can actually program it to hit a dry contact. That 66 is a dry contact, and we can enable another heat device. So something else that's out there. Maybe you got an atmospheric boiler as a backup. Maybe you got an older cascade system, and this is the way to basically enable something to basically have this added boiler kind of operate as the lead until it can't handle it anymore, and then it pulls on an older cascade system, and that's kind of you're starting to replace the boilers one at a time. So there's some options here with this additional call for heat that are quite valuable. And then of course we have the same thing. You can have the additional call for heat with either the set point, floating set point, or floating modulation of the burner. So this is no different really from what we have on 0 to 10 currently. So if you're using 0 to 10 on our existing boilers, same kind of idea. You send the boiler a signal from 0 to 10 volt, and it relates directly to a set point. So 1 volt would be 10C, 10 volts is 100C. So their operating range basically between 0 to 10 is basically controlled by sending that analog floating signal to the boiler, and it responds to that by adjusting the burner output to hit that set point. This is new, and that is basically instead of a set point, The modulation of the burner is capable here as well. So while you're driving that 0 to 10 up and down, the burner responds by modulating the burner by that same percentage. So 1 volt would be 10 volts would be 100% out. So you have that ability to basically operate the burner directly with that setup. The sensor inputs here, we've got the temperature sensor here. This is an accessory, the low loss header sensor. It terminates here on the this output here. You do get a number 5 sensor with every boiler that comes out there. If you don't have domestic hot water, the sensor is the same. It's a 10K NTC sensor. You could use it as the low loss header sensor should you have that capability or requirement. So it's there. We've got the outdoor temperature sensor that comes with every 200 and 100 boiler, and of course a domestic hot water sensor that comes with the boiler package as well. So when we're talking about outdoor sensing, basically the idea with any boiler here is if you want it to be efficient, and that's kind of the whole idea behind the logic of a lot of the controls that boiler manufacturers put into their boiler controls, is the desire to operate that boiler at the peak efficiency. We don't want to basically operate that boiler at the same temperature, 24 hours a day, 7 days a week, 365 days a year. We don't want to fix our temperature at the design temperature. So 75C at -20, we'll keep our thermostats at 20C. Our occupants don't have to put sweaters on to feel comfortable. They're comfortable at 20C there. The idea is that we want to maintain 20C when it's +10 outside. Do we need 75C to do that when it's +10, not -20 outside? No, we wouldn't. So the whole idea there is most of your heating applications, 95+% will react very well to outdoor reset. Whether it's partial, you'll kind of limit it to an area, or you go full outdoor reset, depending on the emitters and basically the system itself, the dynamics of it. You have the ability to do that with a 200, where you can kind of put ceilings and floors or whatever on those temperatures to kind of operate within that parameter. But there's always value in adding that outdoor sensor and putting some reset on those devices. So in this case, we must have a ton of baseboard in here because we can operate down to about 104 degree Fahrenheit, about 40C at +10 versus that 75 C that we were at -20. So, a full on 35 degrees difference. There's kind of a rule of thumb in heating about 3 to 1, where it says for every 3 degrees we drop that supply temperature, we save about 1% as far as energy saving. So 35 degrees there, that's a good chunk of energy, 10, 12% difference between not using the outdoor sensor and using the sensor. And that's without any other, without dialing that in and, after commissioning and really adjusting that output. So the desire here for efficiency is to basically match the heat loss. We're not going to do that if we maintain the same temperature 365 days a year. We have to fluctuate that temperature and keep those thermostats at a comfortable level, keep the occupants comfortable. That's the primary importance. But if we keep the occupants comfortable, at 35 or 40C water versus 75C water, they're gonna notice a large difference in their heating bills and fuel bills. So they're going to be comfortable and they're going to be happy because they're saving money and they'll be able to take those trips to Hawaii that they always wanted to. The outdoor reset curve is on the right-hand side here. And like I say, the heating curves really haven't changed. How you set them up have changed over the years, but really the heating curves have really kind of stayed very similar as far as their function here at Viessmann. Domestic hot water sensor. There's an option with the sensor now with a 200 where you can use an aquastat. You're going to commission that. It'll come up in a couple weeks. So basically, if you have no domestic, you're going to just say not available. If you're using the sensor, if you're using the aquastat, you're going to tell the control what it is so it knows what to look for here on the number 5 terminal for your domestic. And we also have a couple of other outputs here on the MZIO. We've got the CAI, so that's a combustion air interface. And basically, if you have a louver or some type of a combustion air device, we can interlock the boiler basically to not start until we've proven that interlock has opened. So we can power it 24 volts as well, if we need to. but we have the connection right here. So if there's no combustion air device, you leave the jumper in. There's already a jumper in this plug. If you have a device, you want to have that interlock basically connected, you take the dry contact demand and you basically put it across the R&W from the jumper here. And now when that proves, hits the end switch here, closes, the boiler will be allowed, basically released as far as combustion to be allowed to operate. And then of course we see the device here, and we're fully powering the combustion air device at 24 volts. So that interlock is fairly important for a lot of applications. Obviously we want to make sure we are getting combustion air in the boiler room. We don't starve the burners in operation. And one thing here, well, I think the building automation guys will really like is we've got the 0 to 10 volt output here as well. So you've got a feedback that you can interface with your system that will tell you where the burner position is anytime it's firing. So you'll have that information. That burner's at 40%, the burner's at 50%, the burner's at 80, whatever it is at, you'll see it as an output here, a feedback temperature, voltage to tell you what's happening with your system. So same kind of ideas when we're talking about the input modulation of the burner. You're going to see those voltages and the percentage of the burner output related to that way. So low loss header sensors and stuff like that. As I mentioned, it's an accessory with the boiler. This little picture diagram comes in our installation manuals. You'll see there's no low loss header in place here. So this would be kind of like an HC1 where we could use like the outdoor temperature to modulate the boiler pump here. A nice application there. You notice there's no zones or anything else. It's just a one circuit out and back. That's kind of the idea behind that weather compensated operation. If that flow rate, as I mentioned, is above or below your maximum or minimums, then the low loss header is strongly recommended. If you got a lot of zones chopped up in your system, for instance, it's always recommended to have that low loss header, because a lot of times you don't really know what the flow rate is when that one zone opens up there, or those two zones open up together on this side. So if that flow rate's kind of unknown, and the more zones we get, the more vague the flow rate becomes as far as a known value or known quantity. That low loss header really helps to basically mitigate any problems with boiler operation and cycling. When we're piping our system and you do choose to go this particular route, and like I say, there's applications where this would work just fine. It is a fit. You have to be aware of if there were zones in this system and they could isolate the flow of this pump, then there would be some issue there with that pump in operation. But also, if we're operating our system here with domestic hot water, this diverting valve moves from spacing to domestic, and we have our expansion tank over here on the supply instead of the return, the valves here will isolate that expansion tank. And of course, we've just isolated the expansion tank on the supply here from the boiler. So what usually happens is with this type of setup, your relief valve will actually discharge, because your pressure is going to pop as soon as that diverting valve moves to domestic hot water position. So we don't recommend the expansion tanks on the supply of the boiler side like this. We pipe it on the return. When you put a low loss header in, just kind of a identification of what happens inside these either closely spaced tees or low loss header. Fairly important with our systems to know what's happening when we install these devices and what their purpose is. But you've got your piping connections here, so you can see them on the system. And it's all about flow rate when we talk about primary, secondary systems. So when we have the same flow rate on the boiler and the system side, really whether it's a closely spaced tee or low loss header, it just acts like a straight piece of pipe. Nothing happens in the middle of the low loss header when the flow rates are equal. Nothing happens in between the tees when your flow rates are the same on a closely spaced tee system like this. So you can see that everything just flows directly through. And of course, T1, the temperature of the boiler is going to be the same going out to the temperature of the supply. There's no mixing going on when we have that type of operation. All the magic happens when the flow rates differ between the system and the boiler side of your connections here. So inside the low loss header, the whole idea is that we end up with a laminar flow. So essentially, as the water moves into a low loss header, it's built, basically dimensioned to be larger than the connections connected to it. So the water, when it hits this large cavity, slows down, and of course we get this low pressure And that essentially ensures that this boiler side, this boiler pump is not going to push and drive that water through to the system side. We need both pumps in operation to do that through a low loss header. Same with the on the closest space T side, it's a bit different, same kind of concept. The whole idea there is if we looked at a measurement here between P1 and P2, and if we do our pipe connections here correctly, and the rule of thumb basically is 4 pipe diameters on center between your T's. So whatever size this main pipe is here, if it's 1 inch, there would be no more than 4 inches distance between the T's on center. That will mean that when we have a measurement of our pressure gauges, there will be no difference in pressure between P1 and P2. When that happens, the water does not see these T's, these branches. All it sees is a straight piece of pipe. And of course, when this pump is off on the boiler side, this system side is going to flow right past the T's. It's not going to push water in here because it doesn't see a method of doing that because the pressure between the T's is at 0. Once we start turning the pumps on, that's on both sides, that's when, again, the magic starts to happen here. And when you have 6 gallons a minute for the instance here, 10 gallons a minute in the secondary, what happens, we can't have physics basically defied here and have 6 gallons a minute on the supply and 10 gallons on return back to the boiler. There's going to be a bypass amount. The mixing happens when there's differences in flow rates. So coming out of the closest space T system, that's that 10 gallons a minute, 6 gallons is going to basically go back to the boiler, and 4 gallons is going to mix with our boiler supply here to give us our 10 gallons a minute of flow back out to the system. On the low loss header side, the exact same thing is happening. We're getting a bypass of 4 gallons a minute going back up to the system to make our 10 gallons a minute from that return. But that means that our temperatures are different between our incoming and, of course, what's going out. This is a pretty important temperature. This is the one that basically is heating our building. And with a 200 boiler, what you have is the ability of putting that sensor, that low loss header sensor, whether it's closest space T's or you're using the low loss header sensor, or the low loss header. Our low loss headers have a little immersion well that actually puts that in a position to optimize where it senses that temperature. And now the boiler is going to target the temperature here versus the temperature at the boiler. So a really important part of efficiency is knowing what temperature is going out to the system here. And with this feedback to the boiler, it says, not really worried so much about what's happening over on this side. I want to make sure I'm meeting the temperature on this side. So it doesn't matter that T1 equals T2 here, because the boiler is going to target the right temperature for your system with that sensor in place. Some other advantages, obviously, with the low loss headers, add some fluid volume, so some mass. Some of these smaller boilers, a gallon of water, the low loss header adds probably double the capacity of fluid in there, so a little bit more runtime, a little bit higher mass there. You have an air bleed location you don't have on a closely spaced T system. You got air separation, so every time the water passes through this, just like an air separator, it's a multi-pass device. It's going to get rid of that air over time in your system. And it also has a little area here where the debris can fall out and not get back into your boiler loop. You put a little drain valve down there, you can do some maintenance and stuff like that. So there's a lot of added value to the low loss header, and it's engineered already. So based on a flow rate, it's going to work. With closely spaced T systems, it depends on the guy installing it, right? Does he know the rules here? Is he going to apply it correctly? That really depends on your level of knowledge of this whole situation and understanding the dynamics of fluid and how it works, and the necessity of having these connections in the right spot. So a big low loss header there. Some other, getting into the applications here now. So we're almost an hour in, I guess.
You're just a little over an hour.
Okay. So into the applications, we've got the B2HE, and this is the most basic function, I think, on this system. No domestic hot water, one temperature going out to our system. And we've got our primary, secondary on here because you don't know what the flow rates are going on in this particular system. It could change based on the operation here. So in this application, we see the setup of a zone circuit. So we have a couple of options we're going to show you here, depending on the type of system that you've attached here. And we'll kind of try to explain it that makes sense to you. In this application, we got room thermostat. So one central thermostat in the building. It's a power stealing one, so it's got 24-volt AC. So we're powering this thermostat, and when it closes, it's going to turn on our zone pump. So our pump here out there in the secondary is our zone circulator, and it's going to basically whatever temperature we put in there, whether it's looks like it's outdoor reset, we got the outdoor temperature sensor connected here. And of course, that domestic sensor that we're not using, now we can use as a low loss header sensor in this application. And when the thermostat here is satisfied, we're going to stop the pump. And of course, we're going to basically stop the flow rate going through our panel rads. So there's a direct connection between the temperature in the building via the thermostat and the control. But in some applications you might have with, I know with a lot of panel radiators, a lot of cast iron rads, popular use what they call like thermostatic rad valves. So there's no wire anymore going back to the boiler room, mechanical room for this application. You need to basically make sure that this pump can operate without a call for heat, right? Nothing to tell that control that, hey, I need there's no thermostat to tell me. These are basically opening up based on the temperature it senses in the ambient around the room here. That's not feeding back to the control here. So with heating circuits, as you see here, this pump runs continuously. When we set a room temperature that we're desiring, this thing will run this pump continuously as long as the temperature outside is below that room temperature. And it's important to note that, so essentially it doesn't need that call for heat. It's going to keep up with the heating system. The boiler is going to fire and maintain the temperature. This pump is going to pull that temperature around. But think about that for a second. If that's a standard pump and we don't have any kind of method here of bypassing the pump head, if all these rad valves are closed, we're going to deadhead that pump. So with heating circuits, it's advised, put a bypass in here. Variable speed pumps are another good option. Kind of a modern day heating system is, modulating boilers, modulating burners, and modulating pumps that basically complement that kind of whole idea of efficiency drive. So that would be the recommendation there, would be to kind of look at the dynamics. So what type of system do you have? Is it going to be heating circuit or zone circuit? It really depends on, are we operating with thermostats, rad valves, variable speed pumps, 3-speed pumps, that type of information. The other option is we could also throw in, if we don't have a thermostat, we could also throw in a Vitotrol 200. This is an accessory that would be basically you could wire back to the control and mate to that heating circuit. We have these, we've had these, out for, since the WB 2B 200 boilers, Vitotrol 200s and 300s. We have the 200 currently, and basically you can program, this could be like just a remote. So you could, I know a lot of applications and some of the crawl spaces we deal with here, instead of crawling 30 feet, see what's going on with the boiler, they'll just wire one of these Vitotrols and they'll put it outside so that they can just walk by and they can see if there's a fault on the boiler, what's going on with the system. Just a nice visual of what's happening. You don't have to go on down the boiler room to have a look at it. So depending on your occupants, that might be something that's just operating like a remote. You can control up to 4 heating circuits with this. As far as programming the timers and the curves and all that kind of stuff, you can set them up. You can only add a max of 2 of these Vitotrols for any boiler. So if you have 4 heating circuits, you can't have 4 Vitotrol 200s. You could have you designate basically 2 of those Vitotrols to those particular heating circuits. There's also the ability of indoor temperature feedback. So I would recommend this if it's controlling a single heating circuit. If I'm controlling 4 heating circuits, the sensor in where the control is what the temperature is being picked up. So if that's not adequate for the other heating circuits, you might have some issues there. So if it's controlling one specific heating circuit, that indoor temperature feedback is quite useful. That can actually start and stop that heating circuit pump as well, depending on how you program it. There's also an external sensor capability. So you could have the control in one spot and you can have a remote sensor somewhere else. So you got a rental unit or something like that. You can throw a remote sensor in there and you can control the heating via that method as well. So some flexibility there as far as the control. A bunch of things. There's different functions. Domestic hot water temperatures can be adjusted through this. You'll see a fault displayed on this. That's why it's nice just as a remote that can be visual. It'll give you a service indication. That's kind of cool, right? The boilers can now flash up, not gonna stop the boiler from firing, but it will give the homeowner or the decision maker there, hey, it's time to service that boiler. Those reminders are always good because time slips by. and just a nice graphic display as well. So that's an option for the heating circuits to add those Vitotrols into the play there. Now we're kind of stepping it up a little bit here. We've added domestic hot water as the difference. We've got basically a zone set of zone valves here and a zone pump, or we can also use this as a heating circuit as well. So the first one here is looking at it as a zone system. So there's our 3 zone valves. You wire them like you do every other system you've wired. End switches now go back to Z1 here, and we have the 1 zone pump. So this is a 1 temperature for the 3 zone valves when they open up. We're going to only hit that 1 pump output. Looks like we're using outdoor reset. Optional recirc pump here that we have the ability. And remember the 96 plug here, if you wanted to, you could close that. You could use that as a demand for that external pump. There's also a timer that you can use for the domestic hot recirc pumps if you wish. And so there's a couple ways that you can turn this pump on and off, but again, it's just showing it there as an option for you to use off of these controls. And it looks like we selected the domestic hot water sensor in this application. And so that's going to control the pump inside the boiler. The diverting valve is going to close, and we're going to heat that domestic hot water up. We could use depending on how you programmed it, this is where you would actually put that aquastat instead of the sensor if you're planning on using that. We could also use a multi-zone panel. So for some reason you've got whether it's an existing panel there and you're using a retrofit, it's not a problem. It's just a dry contact. Again, the same spot over here. Your 3 zone valves now are hooked directly to the thermostats. And of course, when the end switch is closed down here on the control, it closes our little isolated end switch contact on the unit, and we hit this Z1. You might have a zone panel there. Maybe one of these zones is a priority. You want to have it as a priority zone or something. Maybe it's not a heating loop here. Maybe instead that zone is a spa or something like that. So when that, the time you want to use that, you want to dedicate all the energy to making sure that that spa is heated, then the zone panel might come in handy for that particular application. Zone pumps, again, the ability, remembering that we've got 3 pump capability outputs built into the control, so we can do that without a problem. That's how we deal with that 4th pump output there when we're looking at this. So here's our drawing. We've got our setup here. So our thermostats, or they could be end switches. It doesn't matter what they are, really. These are powered thermostats off the controller here. You can see the 3 wires. They're going to control the zone pumps. We've got a heating circuit in this application. So we got a HC pump, and we're controlling it right now off of the Vitotrol 200E. You don't have to have that Vitotrol in this, but it's an option that we're showing here for this particular application. So that's basically one of these pumps is going to be a heating circuit pump. And of course, it's going to be the one that's going to operate based off of outdoor reset and off of that room temperature. So it'll be the one that's going to drive when the temperature outside is below that room temperature, it'll be the one that's going to go on continuously. So maybe that pump might be variable speed. These ones might be 3-speed, depends on your application. We could also wire that now. This is a bit different, kind of the same concept. We have a wiring little pump module here. You got your 4 zones now wired directly off of this. So we don't control the pumps anymore. We just have the end switch contact going back to Z1. The big difference here is now this is only 1 temperature. So all these systems are going to get the exact same temperature. We're only hitting 1 contact here, and that's basically the difference between those 2 drawings. And again, it might be a priority pump here you want to work with, that you want to desire that maybe maybe it's the pool or something like that, or the hot tub that you want to heat up quickly, and you've got that isolated there, so it's the priority contact. You'll also open up, when you do that, the safety contacts here. So you see that if you have a low water cutoff, for instance, you got some gas pressure switches that you're dealing with here, high and low gas pressure switches. Remember, these contacts, Z1 to Z3, are specific fault outputs. So if I have a low water cutoff, it would go to Z1. If I have a low gas pressure, it goes to Z2. If I have a high gas pressure switch, it would go to Z3, and it's just a dry contact. So the idea here is that as long as that contact is closed, then there's no fault. If the unsafe condition happens and that opens, it's going to open here, and of course you're going to get a fault on the boiler. If you program your 66 plug over here as a fault output, it's going to give you that fault output on that 66 plug as well. So just some flexibility there where you can kind of move things around if you have the desire or need to use those terminals for something else. Moving into kind of multiple temperatures here. We've got two temperatures. We got a fan coil here, and we got a group of radiant, might be staple up, might be radiant inflow, whatever. And we've got the temperature difference here to make sure that we don't overshoot. We've added the mixing valve in here to keep the ceiling of this supply temperature to a maximum. And when we have this particular application, of course, you got your zone pump, so nothing really changes here. We've got the panel from your air handler. And of course, this looks like it's 2-stage heat, 2-stage cool. And they got a fan output here, so all wired up to our thermostat. And of course, you got the heat demand going back to the terminals here to start that pump up. And everything else on this side and the domestic basically stays the same. In some outputs or some applications, maybe that pump is built in to the air handler. I know at our Viessmann Airflow Plus, we have a built-in circulator. So when your thermostat hits that board, it turns the pump on automatically. That's built in, so you don't have a pump output for that particular application. So just a different look to that same application there. Now we're going to move into something a little bit different. We're adding in a heating circuit with a mixing valve in these applications. You see a baseboard high temperature system. We got some panel radiation, and we've got this Viessmann mixing valve. It's typically going to be 4 components that we were looking at. I don't see the 4th component in here. I should have added that in. It will be on for next week. We've got the actual mixing valve itself. So whether it's 3/4 inch, 1 inch, 1 1/4 inch, whatever size it is, we've got the through-A mixing valve. On top of that is an actuator. We've got a control board here, one of those ADIO boards we looked at, the M1 board. And then there's going to be a supply sensor that's missing, that's going to be sitting up in here. And that's going to basically feed back a temperature to the system to make sure we're getting the right temperature out to our panel rad. And the M1 modules look like this, basically. So whenever you have a Viessmann mixing valve system, you're going to have one of these M1 modules, and it has all of the basically components to operate that specific mixing system. So the pump, the 120 volt floating signal for the mixing valve, so it's both power open and power closed. You've got a 10K supply temperature sensor that's going to be strapped onto the supply pipe out to read that feedback, that temperature. It's wired with a plug, so we can plug it in the wall. And then you have your communication over here. So how that looks basically is it just wires back to the plus bus from the EA1 module. So that's our connection. And that feeds back to the boiler, everything from temperature to position of the mixing valve back to the control here. So the boiler control is actually controlling the operation and function of that mixing system via this little plus bus connection. And with this application, you also notice that the domestic hot water tank is on the secondary side of your system. And notice that the pumps here. So when I do this, if I have a recirc pump I want to use and I have a domestic hot water tank loading pump, now I have to add in here, I have to program that. I don't have a heating circuit pump output anymore. So if I did have a heating circuit, I decided to use a heating circuit here instead of a zone circuit on this this baseboard. I could add in a P1 module here, for instance. That would add an extra pump output for me. So this is another one of those ADIO boxes. I thought I'd throw it in there just to kind of explain some of the uses of these pumps. So they give you extra pump outputs when, specifically for applications like this, where we're kind of using that pump as that domestic hot water loading pump here. So again, and the option there would be Aquastat or domestic hot water sensor for that unit. So the 6th layout here we're looking at is basically just adding on an extra mixing valve. Literally, that's what we're doing. We put the domestic hot water tank back on the primary side of your system. And we're showing you 2 different applications here. So you've got the 2 mixing valves. And the key thing here to kind of point out is, you notice how these mixing valves can be, modules can be kind of wired together. They've got the Vitotrols connected to the plus bus directly on there. Then I'm daisy chaining over to the other mixing valve block, and another Vitotrol is being added. And then I'm going from this control back to the 74 plus bus. So it's possible that communication just continues on from one control to another. The difference between this one and the 2 of these is that little dial that's on the mixing valve modules here, the M1s. This one will be 1, and we'll change this one to another value. I think it's 2 on this one to basically operate. So that's how the control will know which mixing valve it's communicating with, is where that dial position is going to be with reference to the position. So everything, they're all defaulted to 1. You have to move the second mixing valve off of that 1 to another position so that the control can communicate with it separately. And the other option here is that instead of this being a zone circuit, we're now using it as a heating circuit. So we kind of went through that already with how to do that. Same idea here is that we're adding those, but with an extra heating circuit, you now have a choice. Do I want to use Vitotrols? And if I'm going to use them, I can only use 2. So which one of these heating circuits will be controlled with the Vitotrol? You'll have to make the decision. You can't put that third Vitotrol in that system. It's not going to operate. And just briefly to kind of throw in here some commercial stuff. We're really going to kind of break the commercial product application out, but I wanted to mention this a little bit, just kind of the stuff that have changed with the controls. We can now run up to 16 boilers on a cascade system. Previous it was 8. Previous to that was 4. So now we're basically every new generation we seem to double the capacity of the capability of the cascade. And so you can now go up between 2 to 16 boilers. And also there's 4 boilers in the system. What you don't notice is the external cascade. Now the boilers are, the cascade is built into the boilers. You're going to select one of those boilers to be the lead cascade boiler. All of the devices, pumps and stuff will come off of that one boiler, and the other boilers will be programmed as lag. And I should mention with the commercial, with cascaded systems, the VitoGuide app must be used. You can't commission it off of the interface. You need to use the VitoGuide app, the VitoGuide mobile app, to basically commission this on site. The other application I wanted to mention here as well is that you can pull one boiler in that cascade system to do your domestic hot water. So instead of the domestic be on the secondary side, you can actually have one boiler as that domestic hot water boiler, but it also is part of the cascade. So if it's doing the space heating and all of a sudden the domestic calls, the cascade will basically flip boiler number 2 on here while this one goes into domestic hot water production. So it really doesn't skip a beat as far as operation. It knows if this boiler that's connected to the domestic is going to have to switch to domestic, it needs to turn a second boiler on to make up that loss. The same idea here is the fact that it's an internal cascade. And basically, when we're getting into the cascade, it's the CAN bus connection that we're dealing with, that 91 connection. And with these, there's a little switch over on the right-hand side, and it's like a end-to-line resistor. We used to have a little dongle end-to-line resistor that we currently use, a lawn resistor. With CAN bus, it's this little switch, and basically we just turn it on for the first and the last boiler in that system. So when we wire the daisy chain here, the boilers that don't have 2 wires going in and out, those are the ones that we're going to switch that basically on, so that the control knows where the end of the network is. And we'll also have gateways. So the Vitogate 300 will not be used with this, with the new boiler product. We have the Wago gateway that's going to be coming out. I wanted to show that to you. And it's basically will be available for all of the current platforms that we support. We can do all these with our Vitogate 300, no difference with the Wago gateway. And it will be available basically in either standalone, or you'll be able to clip it on to DIN rails, on the boiler. So it depends on what type of system. You can buy it with a metal box enclosure, or it'll come so that you can snap it on a DIN rail and do that wiring in the field.
Just a note of that, Scott.
Sure.
That there will be multiple part numbers there'll be a Modbus RTU, a Modbus TCP, a BACnet IP that is built into a specific box for that application. It has the power supply, and if there's a router or something that's required for that application, The individual ones will be, and I don't think they're going to be ready until the commercial boiler is available, because that's the only time you're going to DIN rail mount. They're going to be parts that you buy individually to put on the DIN rail as a kit.
Thanks for pointing that out. Because yeah, I was given the impression that was like the Vitogate 300, which is one component. There's going to be multiples depending on what you have on site here to get the right part number.
Basically, you're going to order based on what protocol you need.
Exactly. Thank you, sir. Moving on to the gas connection here. Nothing's really changed on this side. We've always needed the same connections here on all of our boilers, except the old WB2A 1560 needed a different gas pressure. But the current models are all 4 to 14 inches, so static. When we're running the boiler dynamic pressure, we don't want that to drop down below 4 inches. And of course, you don't want to lock up above 14 inches. So there's some tests there that you need to make sure on your startup. But we want to make sure we get the right gas delivery to the boiler. So this is kind of the piping connection we see in the manual. You don't see an appliance rag anywhere near the boiler in these applications. If you put an appliance rag in here, you got to make sure you follow the recommendations and best practices with appliance rags. If you're too close here to the boiler, that's going to have a high lockup pressure. So that's going to cause or contribute to ignition faults. And basically, that's going to have callbacks, which means that as much as you're going to call Viessmann tech support, you'll also be on site basically dealing with that issue as well, because that rag is basically not piped in correctly. So ideally, when you look at some of the recommendations, you should have straight runs of pipe here, a little bit longer run on the downstream side here. Make sure that the pressure can equalize when the boiler shuts off, so we mitigate high lockup pressures in this case, especially with the ventless rags. In these bigger boiler capacity, you tend to get some higher lockup pressure. So it's always a good idea to leave some piping downstream of that so that we can have some equalization of that pressure to mitigate the high lockup. And same on the high pressure side, some straight run of pipe here, just make sure that the rag can operate and function correctly. Getting into the venting, again, nothing has really changed on the venting side of these boilers. With the exception of, because of the components being streamlined, the vent diameter on the smaller boilers is 3 inches as well. Even though you can vent them 2 inch, there will be reducers to do that. The flue gas collectors and stuff that are all uniform across the product line, so that vent is the same, adapter is the same on all the boilers right across the bit. The little membranes here on the right and left-hand side are different dimensions. You can flip this over to that side and this over to that side, but one of them is 3.5 inch. So if you cut that hole out, it would fit CPVC, PVC, or ABS, and one is 3 1/8. So if you're using PPS for 2-pipe connections, then of course you cut that membrane out and use that one there. And again, you can flip them back and forth. So if you had PPS, but you're over here on the left-hand side, you just cut this one out, flip it over there, take this one here and close it off on that side. So your exhausts are 3 inch. That combustion air intake around the outside is for coaxial venting and single room. So we will remove the little rubber cap for those two applications. That little rubber cap there would be removed for those two. For 2-pipe, we put the cap on and we basically open up one of these connections here, as I just mentioned. And for, as I mentioned, for the room dependent air, recommendation is to open up. Really, only one of the three has to be opened up, but the better one is the ring here. A couple reasons. Something that Curtis brought up in one of his presentations a month or so ago is that, if you have one of these openings here open and you're reading a manual and you throw that manual up on top of that boiler, you might starve that boiler for combustion air just by that little action. Or you got a glass of water sitting up here, or your coffee up here while you're reading the manual, and you knock that coffee over, it's going to go into the hole here. Opening up the combustion air ring here basically isolates that. Very difficult to basically plug that off. So in my opinion, and Curtis changed my mind on that one there, that is the better one on the room dependent air to open up. So coaxial venting systems. Again, nothing sidewall vent or vertical. The dimensions are here. Next week, I should have some I should have some more information on the 2-inch venting. There's some placeholders here for 2-inch as far as the equivalent lengths that you can vent that. On the 3-inch venting stuff, I think there's been actually some improvement on that side. So we'll wait to see what those numbers actually pan out to be. We're just waiting for CSA to kind of cross the T's and dot the I's on the testing. But nothing's really changed here as far as that, your vent calculation, stuff like that. So we can kind of move through that. The vertical vent, same kind of idea. When you're doing multiple boilers, of course, we give you all the distances and stuff are in the vent manual to make sure that we're not pulling flue gas out of this boiler and sucking it back into the boiler beside it. All those things that create havoc over the lifespan of the boiler. But again, some vent calculations here to have a look at. Our tube pipe venting, we haven't changed that either. It's basically these 3 capabilities. We do not do the 4th, which is basically, if you look at that, this hybrid system where the combustion air comes on the side and we vertically exhaust. We don't sidewall combustion or sidewall exhaust and vertically vent or vertically combustion air, because we're going to have a draft being created by this combustion air duct. And that's going to pull that flue gas back through, and you'll damage components with that flue gas moving through the boiler. And that's going to create service issues that we basically don't want to have. It's just time and money that really doesn't need to be spent. Just avoid those types of applications. Your venting here, again, it's all about equivalent length with 2 pipes. So I'm adding my exhaust and my combustion air together. I'm just not doing the vent calculation on the exhaust. This adds pressure drop to the fan as well. So I have to account for it a couple of different ways. These haven't changed from our existing vent manuals. Just some look at the different applications that we're looking at here. I'm kind of breezing through this because there's really not really a lot of difference between these. But if you have any questions, please shout out and we'll try to answer those. Single pipe, room dependent air. Again, you're now responsible for the combustion air opening here. It's a passive opening now instead of directly connected to the boiler. So reference your manuals, your code books for that. Your pressure drop calculations for equivalent length on your elbows and stuff are all in the manuals. Those are all standard, haven't changed from the previous manuals there. And vertically venting, single wall again. So you got multiple boilers like this. Obviously that combustion air opening's got to be that much larger for each one of these boilers. You got to get the total capacity of those units. I just always like throwing this little picture in there. That's a 4 o'clock Friday afternoon service call. Some guy, new house, didn't like the exhaust, taped it up, was up on the roof, and then we get the call. Flexible vent piping, basically the whole idea here is that the flexible vent is always vertical. There's no transition to horizontal with the flexible vent because it will sag and it'll create a water trap. And you lose about 25% of your venting overall. So because of the corrugated nature of the flex pipe, it creates a resistance as the flue gas moves through. So you lose about 20% of your equivalent length with those systems. And we always encourage to avoid storing chemicals, chlorines and salts and stuff like that, pool chemicals and, water softener salts, stuff like that in your boiler rooms, because they off gas and they can actually attack stainless steel, a lot of those different types of solvents, etc. So if your boiler room looks like this, we should change the boiler room because it's not, like I say, it will be problematic for your boilers. And that's just not just a Viessmann thing. That's just a general thing with off-gassing of these components and their effects or impacts on stainless steel. So the last thing to kind of talk about here is the addition of common venting. We've had it before. Just a couple of notes for commercial, those cascaded systems there. Still 4 boilers, can't go any more than 4 boilers. But we've added the ability of going sidewall vents. So I thought I'd throw this picture in here. So it's currently, we used to be always, must be vertically vented, the boilers. And of course, depending on the, the building and stuff, that could be quite extensive. So now we can do sidewall vent. Not that it's always the best application, but there is an application now that you can fit into your systems. We're allowing it to happen. And we've added over on the left-hand side, there's another check valve that's going to end up on the exhaust side, essentially. So now the benefit of of that is for service, as well as a few other benefits. The big one there is service. So now when I'm servicing boiler number 1 there in the picture, I can turn that boiler off, remove the burner, and I can let the other 3 boilers fire, because now I've got a check on the exhaust that will allow me to do my service without having any issues on that particular side of it. So just thought I'd mention that as well. Again, we're going to get deeper into the commercial stuff. It's almost it is a presentation on its own, kind of going through the whole commercial setup there. But I wanted to give you a little teaser just to kind of get your minds kind of interested in that.
And just
So that's
just
all I
a
had to
side-
say today.
Can
Yep.
I just interrupt you for
Go
a
for
second? Okay. Just a side
No.
note on the. Okay, sorry. I'll be quiet now. You can't tell me what to do. You're too far away.
Go for it. You're the
Okay,
boss.
so the common the common vent applications are not available yet for the boilers. They were still waiting for some materials for the common vent check valves and stuff. So that won't be available. You won't be able to common vent these boilers until probably later in August, before you can do those applications. But there's also a limitation on when you can common vent, because if you're common venting, you're doing multiples, and some of the applications for common for cascading is also going to be available around that same time. One of the things that questions that we've got in previous training was that that check valve has to have a condensate trap. Well, the condensate trap is built into that check valve, so you don't have to put an additional condensate trap on an individual check valve in the vent. It's already built into the actual valve. So that's all I was going to say.
Excellent, man. That's really good information. I wasn't quite sure. I've heard about something about that condensate there, so it's good to know that that's been addressed. But that's all I do have to say, actually. So if you have any questions, we have any questions out there, Mark, Curtis? All good? Well, if that's basically, if that's we don't have any questions.
Oh, sorry, I had my mic off.
Oh, no worries.
No, we had 12 questions and we kept up with them all.
Oh,
So
sweet.
we will have all the questions in a document that'll go with the PDF of the presentation.
Excellent. So that's the benefit of having three instructors for the price of one, that you get your questions answered immediately.
That's right.
So we're going to do this again next week. I think next Tuesday we have the 100 training again. And we'll have the 200 training, this exact same presentation next Thursday as well. I'm fairly certain that's when it is.
Yeah, but you don't have to get up as early next week because it's in the afternoon here.
Exactly. So I'll be, I won't be in my pajamas next week. So I'll be have my usual work garb on, and we'll be going through this again. So if you have other workmates, or think that this would be valuable for somebody else in your company, or a friend or whatever, let them know that's going on. It's easy to sign up. Just go onto our website. You'll see online seminars, and you can just follow the links, and you'll be able to register for this. And our marketing team does an awesome job of putting that stuff all together. They'll send you a link to the information, and they'll make sure you get on to the presentation when it's time to do that. So we look forward to seeing you guys or your friends or whatever next week. And make sure you kind of follow up, because we're going to be doing the commissioning and startup following this. So it kind of all leads, kind of each kind of presentation leads to the next one. And that's kind of the finality, is the commissioning and startup side of it. So there'll be lots of really good information there that will complement, hopefully, what I kind of try to explain in this presentation today. So thanks very much, and we'll see you next week, hopefully.